Hello my dear students, in this video we are going to learn some of the basic concepts of motion that are there in class 9 physics in the chapter called motion. Now motion, this word motion, it means movement. The literal meaning of the word motion is movement. Now in physics we define motion of an object, that is the definition for a moving object is given as the change in position of the object with respect to its surrounding or a given reference point or a taken reference point with the passage of time. Now to clearly understood this definition we need to know the concept of position at first. The concept of position should be clear to us, then only this definition will be clear to us. Now when we define position, we say that it is a place where someone or something is located or is being kept. This position will be clear to us through this example. Let's say we have a tree here in a certain location and we want to determine its location. We want to specify its location, its position. So I say that it is located 4 meter to the east. But this sentence also is not clearly defining the position of this tree, because this 4 meter is not saying the tree is 4 meter from where, and this direction east is also not defining the position of the tree, as it is not clear the tree is to the east of which place or what. So for that reason what we need is that whenever we are defining the position of an object, we need a reference point, and this reference point is generally a part of our surrounding. Let's say for this case we take a house here. Let's take it to be my house, Suman sir's house. So from Suman sir's house the tree is 4 meter to the east. Now the position of the tree is clearly defined, as it is saying that this tree is located 4 meter to the east of Suman sir's house. So now the position of the tree is clear. This is what position actually defines. But we know very well that in our surrounding we do not have only a house, but there are several other things. So we can take several other reference points. For several other reference points, the position of the tree will be different. This conclusion that the position of the tree will be different for different position will be clear by the next example. So let's say we have 4 persons A, B, C and D who are sitting in a row from left to right, and they are equidistant from each other. Okay, now we want to determine the position of B with respect to the other 3, that is position of B with respect to A, C and D. Now if we take A to be the reference point, the position of B will be to the immediate right of A. Okay, position of B with respect to A is the immediate right, while the position of B with respect to C will be to the immediate left. The position of B with respect to C is to the immediate left, while if we take the reference point to be D, for D the position of B will be second to the left. Clear? from here we can conclude thus that position is relative, which varies according to the reference point, taken reference point. Okay, clear? Now there are two types of position. One is referred to as relative position, the other is referred to as absolute position. Okay, so relative position is the one which we take as relative, which will vary from instance to instance, but absolute position will be a fixed position. Okay, and it is taken from an absolute point. Okay, if we take an absolute reference point, we will get an absolute position. If we take a varying reference point, then the position will be referred to as relative position. Now this we will try to understand with this coordinate. Okay, so here is we have a coordinate, and there are two axes. One is north to south and the other is from west to east, and these four uh, directions for these two axes, north south and west to east axis, they divide this coordinate, or divide this uh, graph into four quadrants. The first quadrant is in between northeast, the second quadrant is in between northwest, the third quadrant is in between west south, and the fourth quadrant is in between southeast. Okay, and in these four coordinates we have four objects. Let's say B in the first coordinate, A in the second coordinate, C in the third coordinate, and D in the fourth coordinate. Okay, now A, B, C and D, here these four we take as varying reference points. They vary after time to time, they vary. So the position of an object with respect to them, that is with respect to A or B or C or D, as they are varying reference points, the position will be a relative position. Okay, so let's say we are to find out the position of B with respect to A. Position of B with respect to A, then we will find that the position of B with respect to A is to the east, while the position of B with respect to C, that is for C, the position of B is to the northeast. Okay, for A, the position of B is to the east, and for C, the position of B is to the northeast. Clear? So this type of position is the position of B is varying, as A and C are varying reference points, so the position of B will vary according to these two reference points, A and C, and this type of position is referred to as relative position. Okay, clear? Now in some cases, let's say we want to consider this whole in one frame, then we have to take one absolute point, a position which is fixed. Okay, a fixed reference point, an absolute reference point. In this case we take O as the fixed reference point. Then we will find that the position of all other points, that is A, B, C and D, all these points will be their absolute position. Okay, the position of A, B, C and D will be their absolute position. Okay, so if we take O as the fixed reference point, we will find that B is to the northeast of O, A is to the northwest, C is to the southwest, while D is to the southeast. Okay, and so on. Here we should keep in mind in these 2 points. We can take any point as absolute according to our convenience. For in this case, we have our convenience was to take O as the fixed point, so we have taken O as the fixed point. If your convenience is to take C as the fixed point, you can take C as the fixed point or absolute reference point. So it is not necessary that O will always be the fixed reference point, but for our convenience we have taken here O as the fixed reference points or absolute reference point. The next thing, next point that we should remember is that direction as well as distance both is required to know one's position. If we want to know the position of an object, we need to know the direction as well as the distance for understanding the position of an object. Okay, clear with that? Okay, now following this explanation of position, relative and absolute position, we have a set of question here. 5 questions are given and all 5 questions are related to position, and here the graph is given. You can take the help of the graph and try to answer the questions that are given here and send it to me to my personal WhatsApp number, which is given in the class 9 group. Okay, now as we have understood the concept of position, now we are ready to understand the concept of rest and motion. Okay, so in mechanics, or what we are studying right now, that is motion, while we are studying motion, we find that there are 2 states, the state of rest and there is the state of motion. What does the state of rest say? The state of rest says that an object is at rest, an object is stationary, while that of motion is, what does it says? That it is, the object is moving. So we will try to understand them, the rest and position, rest and motion. So here let's say we have an object here, and this object, we are noticing this object, we are observing this object from a reference point. Here I have a house here. Okay, here I have a house here. Okay, let's say again Suman sir's house. So from Suman sir's house, Suman sir is observing this object. Okay, observing this object. Now this object, as the time passes by, is at the same distance. Let's say it was at first at 6 meter to the south of Suman sir's house, and it is still at that position. The time is passing by, 1 second, 2 second, 3 second, and so on, hours and hours it is passing by. The position of the object is not changing, so we say that the object is at rest. Okay, time is passing by, but the position of this object is not changing with respect to Suman sir, so this object is at rest. Okay, now if the position of this object shifts, let's say even the direction shifts. Okay, 6 meter to the south it was, now it became 6 meter to the southwest. Okay, 6 meter to the southwest. Then as the position is changing, as the position has changed, we say that the object is in motion. Now continuously, let's say the position is changing. From southwest it went to southeast, then to northeast, then again to northwest, then again southwest, and so on. It is continuously changing its position, and also the distance is changing. Let's say from 6 meter it has changed to 4 meter, then again to 5 meter, then again to 10 meter. So it is continuously changing. The position of the object is continuously changing as the time is passing by. For Suman sir, the position of this object is continuously changing. Then we say that the object is in motion. Okay, clear? So here we can define rest and motion in this way then. Okay, wait for a second. Okay, here it is. Okay, now here as it is defined, rest, we can define rest, a body is said to be at rest, said to be in rest if its position does not vary with respect to a given referral point as time passes. Okay, so this is the definition for rest. And for motion we can say so now that a body is said to be in motion if there is continuous change in its position with respect to a given referral point as time passes. So clear? from the previous example we can say that position, a body is said to be at rest, a body is in rest if its position varies, if its position is varying, is not varying with respect to a given referral point as time is passing by, while motion, in case of motion, it is varying, that is changing, the position is changing continuously with respect to a given referral point as time passes by. Now there is a third point which says that concept of rest and motion is related to referral change in position. So a single object can be at rest or motion same time with different referral points. At the same time an object can be at rest and motion. This is what the third point is saying. And if we consider a single object, as referral point and consider it as rest as an absolute, consider it as to be at rest, then as an absolute point any object which is at rest with respect to that point is considered at rest, and same case with motion. Okay, so if we take an absolute point, then from that absolute point, if a position, if absolute referral point, then from that absolute referral point if we take the position of an object that is not changing, or the object is at rest, then that is the absolute position of that object. Okay, absolute state of that object. Why? And the same can we derive for motion. Now the last point says what the last point says. In general, we consider Earth as absolute point, considering it at rest, although it is in motion with respect to Sun and other planets. Now Earth is a very giant planet, although not the largest planet in the solar system, but it is very giant for us. So in that case we can consider the Earth to be an absolute point, absolute referral point, or certain objects within the Earth to be absolute referral point. But as we know very well that Earth is not in rest. Earth is not at all at absolute rest, as it is going around the Sun, and so thus we can consider about the Sun. The Sun is also not absolute. So in reality, in the universe there is nothing called absolute rest position. Okay, now these 2 points that we have discussed, that is an object can be at rest and in motion at the same time, and that if we consider a point to be an absolute point, then from that point an object could be at absolute rest or an object could be at absolute motion. That we will learn in the coming example. Okay, so here we see a person is sitting here. Okay, this is a train, and this is a train, and this person is sitting here, and this is a train. Okay, and the person is in a train, okay, and the person is inside a train, and there, let's say there is a co-passenger here. Okay, co-passenger here. For this co-passenger, this person is not moving, the person is at rest. While if we consider a person observing from this house, if a person is observing from this house at the train and sees this person, for this person here, he is moving as the train is moving, as he is moving with the train. Okay, so you see how it is considered. For this person is at rest, while a person who is outside in his house, for him observing the train moving, will observe that this person is actually moving. So the same person, this same person is at rest from this reference point and is at motion from this reference point. Okay, now if we consider this to be a fixed point, as it is not changing, then we will find that the absolute position of this person is actually what? The absolute absolute state of motion state for this person is that the person is in motion. Okay, now here we get the concept of relative motion. For this person the object is at rest, for this person the object is in motion. So this defines relative motion. Okay, clear? Okay, now let's get on to the next. Next we have the two terms called scalar and vector quantities. Okay, so before going on explaining scalar and vector quantities, we should know that there are certain quantities which are measurable and there are certain quantities which are not measurable. Okay, so if, as we are not to deal with non-measurable quantities, here we will be discussing about measurable quantities. So measurable quantities, like we have distance, we can measure distance, displacement, speed, then velocity, then acceleration, gravity, okay, gravitational force, sorry, not gravity, gravitational force, and so on. These things we can measure, so they are considered to be measurable quantities. Now these measurable quantities are classified into two groups: scalar and vector quantities. Okay, scalar quantities and vector quantities. What are these scalar quantities and vector quantities? Let us understand them. So here we see that there is a line segment here, AB. AB is a line segment and the length of the line segment AB is L. Okay, there is a line segment AB and the length of the line segment is L. Now we can measure AB from any direction, let's say from A to B or from B to B. So it doesn't matter, the direction of the line segment doesn't matter. If we are not measuring its we are not observing, we are ignoring its direction, we are only measuring its length, then we'll find that the line segment AB is a scalar quantity, as it is defined only by its magnitude. Okay, so AB is a scalar quantity as it is defined by only its magnitude, but the directions are not specified. Now if I take another line segment, let's say another line segment AB, which is directed from B to A. Okay, there is a line segment, let's say BA, which is directed from B to A, and its length is L. Okay, so as it is directed, the magnitude is L, but as it is directed, so it becomes a vector quantity. Okay, BA is a vector line segment, we can say. Okay, and similar is the case of this one, the next one, that the line segment is directed from A to B and the length is L. As it is directed, so it is a vector quantity. So we have two vector quantities here, one is AB and the other is BA. Now we observe that both of their magnitudes are same. The magnitude of BA is L and the magnitude of AB is also L. But the vectors are not equal as they are directing in two opposite directions. While the line segment BA is directing from B to A and the line segment AB is directing from A to B. So they are equal in magnitude but opposite in direction. So when we mention vector AB, when we relate vector AB to BA, we can write it in this format: AB is equal to minus BA or negative BA. The negative sign here describes the direction. Okay, their magnitude is same but the direction is opposite to each other, so the minus or the negative sign implies the opposite nature of both of them. Okay, here as we say, vector BA is not equal to vector AB as their directions are different although they are equal in magnitude. For two vectors to be equal, both direction and magnitude should be equal. Since both vectors are equal in magnitude but just opposite in directions, we can write vector AB is equal to minus vector BA. Okay, clear? So we can take here example how a vector could be equal. We have a vector CB, let's say. Okay, CB, and it is directed from C to B. Okay, L, and its length is also L. The line segment CB also measures L, so its magnitude is L and it is directed from C to B. As we can see, the direction of A to B and C to B are equal, so AB can be considered an equal vector to CB. Okay, clear? Okay, now let's jump on to the next section. Okay, before jumping into the next section, we should understand, as we have learned what is a scalar and vector quantity from the first slide, from the second slide, we come to know that the position is a vector quantity. Okay, position is a vector quantity as it has both magnitude, that is 4 meter, and direction, that is east. Okay, as position has both magnitude and direction, so position is a vector quantity. Okay, we will learn about scalar quantity in the next one. Okay, so next we get is what is called distance and displacement. Okay, distance and displacement. Distance, when we define, we say that it is the actual path covered during motion of a body, while displacement is the change in position made during motion of a body. Okay, distance is not required or is not needed to be the shortest path between 2 points, while displacement is the shortest path between the initial and final position. Okay, the initial position from where it moves and to the final position where it moves. Here in case of distance, it doesn't matter so which is the initial point and the final position. We just have to measure the total path. But in displacement, we have to measure the we have to find out the initial and final position. Okay, now distance, as it does not require direction to explain, so it is referred to as scalar quantity. Here one thing you should keep in mind, that the spelling of scalar is wrong here. Okay, sorry, spelling of scalar is wrong here. It should be SCALAR, not ER. Okay, now next, that displacement is a vector quantity. Okay, as it requires direction to be defined. Distance, we can take example of distance to be scalar quantities, like we can measure distance of a road as 4 kilometer. So 4 kilometer is a 4 kilometer, we are only measuring the distance, so we are not mentioning any direction here. So for distance becomes an scalar quantity. 4 kilometer is a scalar measurement. For vector, for displacement, if we go for displacement, we will find we are mentioning 4 kilometer to the west of some place. Okay, to the west of some place, I'm not mentioning the place here. So let's say 4 kilometer to the west of VKV. Okay, a place is 4 kilometer to the west of VKV, so we are mentioning here the distance as well as the direction. So distance along with direction is known as displacement. Okay, now let us understand this with a diagram here. Okay, so here we have a object moving from A in this way, in the path from C along with C to D to B. Okay, so it is taking this path. When it is taking this path, what is happening? It is taking a long path to reach B. Usually the roads are curved, so this is the long path. Okay, this is the distance, the long path. Okay, and the lengthier path, the actual path which is being taken, is referred to as distance, while displacement is the shortest distance. You see, from A to B, the shortest distance is referred to as displacement. Clear? So let's say the actual path of a body covering from A to B through C and D is 4 kilometer. Okay, while the displacement could be 2 kilometer, that is the shortest distance from A to B could be 2 kilometer. Okay, here you should keep one thing in mind, that displacement and distance can be equal. Okay, can be equal, but distance is never lesser than less than displacement. Okay, distance can never be lesser than displacement. That is, if we say that this both distance and displacement could be equal to 0, okay, when there is no movement, and when an object is at rest, the distance and displacement both are equal to 0, and here displacement can become negative, okay, negative minus 2 kilometer, but distance will always remain positive and will never be less than displacement. Okay. Okay, now here is another figure given here. You can try to understand uh, by yourself this second. From this second figure you can try to understand, what distance and displacement is. As we can see from B, let's say we are taking this path, this long path, then this long path, this actual path that is being traveled is referred to as distance, while this shortest path, although I have taken this path, not this path, even then I will consider this shortest path as the displacement. Okay, clear. Okay, now let's get back to the next diagram, where we have circular motion. An object is going circular. Okay, now if let's say here we have an object O which is moving from A to, which is moving from A to B. Okay, an object O is moving from A to B through this arc, that is passing through C, okay, in this direction. Then we will find that the distance covered by this object O, is x equal to pi r, where x is the distance covered and pi r is the circumference of this semicircle. Okay, and displacement, in this case the displacement of O will be the diameter of the circle. Okay, diameter of the circle will be the displacement, where here it is represented as d is equal to 2r, where 2r is the r is the radius. Okay, r is the radius of the circle. Okay, now suppose a boy is running, that is here, as we have considered here O, let's say this O is a boy and he is running on this track, and he starts from A. He starts, okay, moving, and he completes one round, okay, complete one round of the circle. Then we will find the distance x is equal to 2 pi r. Okay, distance x is equal to 2 pi r, where 2 pi r is the circumference of the circle, that is the perimeter of the circle. Total distance covered by the boy while going round the circle is 2 pi r. But as the initial position, that is A is the initial position, and the final position, that is A, that is also A, is the same, therefore the displacement is 0. Displacement is equal to 0 here. You see here displacement is equal to 0, but distance is 2 pi r. So you see that distance can never be smaller than displacement. They can be, both can be equal, but they can never be equal. If an object is traveling in a straight line, then displacement is equal to distance. But if they are not traveling in a straight line, if the path are not straight, then we will see that displacement is always less than distance. Okay, obviously both can be equal to 0 also, and displacement can sometimes be also equal to negative integer. Okay, negative value. Displacement can also take up negative value. This we will understand in the next video. Okay, so hope you will understand this video and share your views. How was the explanation? and the questions that were there, these questions, okay, the answers to these questions should be sent to me immediately. Okay, thank you.